Alright guys, welcome to our channel once again. Today we'll learn about general nomenclature. So nomenclature in chemistry means the system by which names are given to compounds. So we know that due to the existence of millions of organic compounds, there is an eminent need to identify organic compounds in specific names, hence the general rules for naming organic compounds. So the earliest known organic compounds were actually named from their sources. For instance, the formic acid is named from Formica, which is an ant. Hence, organic chemists soon realized that this will lead to memorizing of several thousands of names. So the chemical society of different countries operated in developing the sets of rules for naming compounds. This society is the International Union of Pure and Applied Chemistry, and their rules are called the Iupac rules. So let's quickly go ahead and discuss this. So the basic principles that must be followed or that must be observed while naming organic compounds are as follows. 1. Identification of the parent hydrocarbon chain. Now the parent hydrocarbon chain is the chain with the maximum number of substituents, multiple bonds, and maximum length. So 2. Identification of the parent functional group. So for organic compounds with more than one functional group, the group with the higher priority is given the parent name, while the rest are substituents. Identification of side chains. These are carbon chains that are not in the parent chain. Next, identification of the substituent functional groups. Now this refers to the functional groups which are not the parent functional groups. Iupac rules require that the names of substituents be assembled alphabetically. When two or more groups are on the parent chain, each of them is named and located by a number. So next, identification of double or triple bonds. And then finally, numbering of the chains and substituents. So I'll go ahead and give you the prefix names for number of carbon atoms in each organic compound. So when we have just one carbon, it is named with the prefix met. So example is the methane, which is CH4, just one carbon. When we have two carbons, it is named with the prefix ate. So an example is ethane, which is C2H6, which can be written also as CCH So when we have three carbons, the prefix is prop. So example is the propane, which has 3 carbon chains, which is also C6C3H8. So the next is 4 carbon chains, which has the prefix but. So example is the butane, which is C4H10. You can also write it as 1, 2, 3, 4, then add the hydrogens. Alright, so go ahead and wipe this, so we'll continue from there. So for 5 carbons, we have paint, which is 1, 2, 3, 4, 5. Then we have so for 6 carbons, I have hex as a prefix. So this can be written as C6H14, or you can still write in this form. When I have 7 carbons, I can have the prefix hept. And then 8 carbons is oct. Example is octane. Octane. Example of this is heptane. Example of this is hexane, which is this. This is pentane, which is this. This is for 9C, I will have none, of which an example is nonane. And then for 10 carbons, I will have dec. So subsequently, I can have 11 carbon, which is on dec. I can have 12 carbons, which is dodec. So this is how you basically add prefixes to your naming of your compounds, depending on how many carbon chains you have within. Alright, so let's wipe this and go ahead with the next. So if I want to name substituents, for instance, the substituent NH2 will be amine. The substituent OH will be hydroxy. Will be named as hydroxy. The substituent NO2 will be named as nitro. So the substituent SH will be named as mercapto. The substituent Cl will be named as chloro. So the substituent ELF will be named as fluoro. The substituent Br will be named as bromo. The substituent I will be named as iodo. So the substituent 6,6H5 will be named as phenyl. So when you have O double bonded to C, to the carbon, you call that oxo. So let's take note that O is usually double bonded. So when you have O with an alkyl group, you call that methoxy. So this is basically the major substituents we'll be working with. So it will be of importance that you memorize all these. You have NH2 as amine, you have OH as hydroxy. When you are naming as substituents, you have NO2 as nitro, you have SH as mercapto, you have Cl as chloro, you have fluoro, you have bromo, you have iodo, you have phenyl, you have oxo, you have methoxy. So these are the substituents you need to memorize. So let's quickly go over to the next, which is listing all the substituents according to their priority. So we have the functional groups or the substituents according to their priorities. All right. So over here, we'll go ahead and list all the functional groups according to their priorities. So if I have to make a table of this will be the structure. And then this will be the name. All right. So the first is the onium ion, which is NR3. So this is onium ion. So the second is the sulfuric acid. The sulfonic acid. So we have next acid halide, where X can be iodo, can be bromo, can be chloro, can be fluoro, or any halogen. So we call that acid halide. So we have the amide, which is amide. We have the natural, the nitrile, so we have the nitrile, which is also cyano, or nitrilo. We have next the aldehyde, which is CHO. So next we have the ketone, so let's go ahead and wipe this. So next is the phenol, which is an aromatic hydrocarbon with an OH. So the next is an alcohol, which is an alkyl group with an OH. So we have the mercaptan next, also known as the thiol. So thiol or mercaptan. So the next is amine, which we can also name as an amino. So next we have the double bond alkane, always denoted by "-ine", and then the triple bond alkyne, always denoted by YNE. Alright, so guys, this is a table to show you the priorities for the different functional groups. So we'll go ahead and consider the Iupac rules for naming alkanes.